Morning, kids. In today's class, we are going to discuss about the problems related to inclined projectile. So let me explain the question. I have the two plates, AB and CD, are rigidly attached perpendicular to base of a massive box. Massive box. Okay, this is the massive box. What is a massive box? This everything is a massive box. Huh? Fine. Then in this particular massive box, we have attached two plates, rigid plates, AB and CD. They are fixed to the plates. Attached, rigidly attached to the box here. So now after this, the box is released on the smooth inclined plane. Okay, this particular thing will choose this is theta. Let me choose this one in all our calculation. So this is the inclined plane. No? Inclined plane. So next, after this asking, with what minimum speed with respect to box, a particle is projected so as to graze the point A like this. It will move A and C of the plate, AB and CD. Okay, fine. So what is the condition given? The condition given is when you project the particle from here with the speed u, so the moment you release the box, the box will start accelerating down, and the particle is projected at that instant from here. Then the particle weapon should go here, should graze here, and should go like this. I will show clearly. So the particle should have a trajectory such that it should cross the top of it should just graze the point A and C of the plates, of the plate AB and CD. So what are the plates here? These are the plates. These are the plates. So we have to calculate this particular U. We have to calculate this particular U. Okay, now what are the conditions? Like how to manage this? Is it a really relative projectile? Yes, you can make it a little bit very simplified. Let this acceleration due to gravity will resolve this G into two parts. Choose some other color. So if you resolve this G, so this will become G cos theta, G sin theta. So the acceleration of box will be and that of the particle also. Particle also will have acceleration. Box box will slide along the inclined plane. Box will slide along the inclined plane. So here the box which is there, the blocks will have acceleration along the incline how much equal to G sin theta. What about the particle? Particle when it is moving in air, it will have two accelerations. One G sin theta, other will be G cos theta. It will have two accelerations. So we'll show somewhere here. The acceleration of the particle will be G sin theta, G cos theta. So now you can check it here. So what is the acceleration of box? Acceleration of box is G sin theta. So is there any like what type of motion along the inclined plane with respect to box? The particle is going to describe uniform velocity motion along the inclined plane, and perpendicular to plane, it will have acceleration G cos theta. Acceleration A parallel, I'll write it here. This is a parallel. This is a perpendicular direction. What the acceleration of the particle with respect to box along the incline? We'll write it here. Acceleration box, acceleration of particle with respect to box along the inclined plane in this parallel direction is how much will write acceleration of box minus acceleration of particle along the incline. Acceleration box along the incline, g sine theta. Acceleration of particle, g sine theta. So this will be 0. So therefore the particle, acceleration of particle along the incline with respect to box will be 0. So what is the conclusion we make it? Particle describes uniform velocity motion with respect to box along the incline. Uniform. How much that velocity? So we will take this is alpha. So how much it is equal to mu cos alpha. So this u is what unknown thing which we have to find out. I'll add. Then acceleration of particle with respect to perpendicular to inclined plane. Acceleration of particle with respect to box perpendicular to the inclined plane. A perpendicular equal to acceleration of box perpendicular to inclined plane minus acceleration of particle perpendicular to inclined plane. This will be 0 because box cannot move in this direction. Box will move only along the incline. It cannot move up. Box will not lose contact. So it will slide along the inclined plane. So the box will have only g sine theta along the inclined plane. Okay, so this will be that of the particle g sine theta. Okay, fine. So there's a one basic idea of the or entire problem discussion. A perpendicular, A parallel will be 0. And that is separately. So now we will make this our entire problem with respect to along the incline and perpendicular plane. Now, what is the condition? When the ball which is projected, it has to go in a parabolic path and it has to just cross the point A and C of the plate. It has to graze. Graze means just it has to cross at these points. Okay, so for this, we will take help of the diagram. Here it will have some velocity. Here it will have some velocity. Now the velocity at this point, let it be say V. VA, I'll write it. Velocity when it is crossing here, let it be VC. And initial projection at the point of projection, let it be U. Okay, now we have to get that VA and VC. Now we'll look at this particular pointer. The same diagram, let me give a better clear picture. Here it will have velocity, here it will have velocity. So let the velocity at this point, let it be VA. And this length, it is given equal to AB equal to 2 meters. This length, it is given total CD equal to 3 meters. This is 1 meter. Okay, I agree this. Then the distance from A to C is 3 meters. Distance given separation between top of the plates is 3 meters. So this AC given 3 meters. AB 2 meters. CD 3 meters. So we know this distance also. So we will draw that triangle. This given 3 meters. We'll have that triangle. Okay, this is the point A. And this is the point C. Here it will have some velocity. B. It will have some velocity. We say we are okay. Now we have to get the value of U. Now you are projecting with a speed U from this pointer called point O. It will move in a parabolic path, and it has to graze A and C. So we'll calculate, and it's telling that minimum velocity, and that too minimum possible speed relative to the box. So therefore now, if you project with the minimum speed here, then it will also have the minimum speed at point A. So we'll use the formula minimum speed for a particle to cross through a pointer. We are going to use what is the concept? Minimum. Or what is the idea? Minimum speed for a particle to pass through a point. Minimum speed at point of projection for a particle to pass through a point. What is this? Suppose if this is the what minimum speed you should project so that it should cross through this particular pointer. Hope everyone, I think you have some idea related to this. U minimum, say some 5. So what the formula for this will be? U minimum equal to root of G in basics of projectile. I think I explained all this. Just go through my earlier videos. So with what minimum speed you should project from the certain point so that it should cross through the particular point. And what is the point? The coordinates of the point are x and y. Okay, and this is the speed needed. Okay, now similarly, the same thing applicable for point A to C. This idea will apply from A to C. So what should be the VA equal to? VA equal to, I think this will become Y. I think we don't know this distance. We don't know this. That will calculate. This I'll call E. We have to calculate E. No? Let me calculate that distance E. This will be 3 square equal to y square plus E square. 9. Y will be 1. So AE will be 2 root 2 meter. Okay, this length will be 2 root 2 meter. This is 2 meter. Okay, now we know this distance 2 root 2 meter and this will become x. So we'll calculate that minimum speed V. So what's the minimum speed of the particle which I'm projecting from point? Actually, I'm projecting from O, but okay, I can apply the projectile motion from A to C also. So here it will move like this. This length is 3 meters. Okay, now we'll apply the formula. G into this will be value of y. Y will be 1 meter, 1 square, 1 plus root of. I'll call the same formula. Let me write it. G into y plus substituting all the values. G will be 10. Value of y will be 1 root of 1 square I'll write all the things clearly. This will be 2 root 2 whole square. Okay, we'll simplify this. Speed of the particle when it is grazing the plate AB, speed of the particle. What is VA? Speed of particle. Speed of particle we have projected from point. Speed of particle at point A when it is grazing the plate AB, and that is what VA we are telling. Okay, this should be equal to 10, 1 plus 1 plus, okay, this will be 9, I think will be 3. 2 root 2, 4 to the 8, 8 plus 1, 9, 9. Root 9 will be 3, 3 plus 1, 4. This will be root 40. To root 5. To root 10. Okay, this is the speed of the particle it is. So what we should call speed of particle at A. Now we have to calculate the U, no? So how to calculate that U? I'll apply the projectile motion. Now you can ask questions like why there is no G sine theta. Already I told you the particle will have G sine here. The box will have G sine theta and the particle will have G sine theta. And only there'll be G cos theta. There'll be no relative motion between the particle and the box along the incline. There'll be relative motion between the particle and the box perpendicular to incline only. Okay, now let me apply this. So this angle, we have to calculate this U. We have to calculate U. If we know the work-energy theorem directly, we can apply it or we can go for projectile motion. I'll apply conservation of mechanical energy. Conservation of mechanical energy from O to A. This should be equal to mu square by 2 equal to mg into AB. M height will be g cos theta into AB. plus m VA square by 2. So this will become u square equal to g cos theta. The length AB, we know. Why you have to ask question like, sir, why g cos theta? What is the acceleration due to gravity normal to incline? Usually in all our problems, this will be g, no? I think, yeah, let me do correction. I'll come back. Here it should be g cos theta. Why g cos theta? This acceleration of particle normal to incline is how much? Will be g cos theta. So 10 cos theta cos 37, 4 by 5. Let me redo this part. Okay, this what is cos theta? The value. Huh? Once again, I think I forgot this cos theta. Let me include here. Here we are discussing. If you are discussing with respect to ground, here it will be only g. Fine. But here what happened? We are having something like a normal incline. So g cos theta has to come. So this will be 8 will come. 5 2 ja, this will be 8. 8 4 ja, 32. 4 root 2. Let me, okay, now once again, so why g cos theta? G cos theta AB. We are applying conservation of mechanical energy from point O to A. Will be very simple. We can take help of kinematics, since most of you know some basics of conservation of mechanical energy. I'm explaining here. So from when it moves from O to A, you can apply conservation of mechanical energy in projectile motion also. So then in here kinetic energy mu square by 2. Here mva square by 2. That's what is the height? Height will be perpendicular to incline. Mg cos theta, the distance AB. Okay, fine. So this is the reason why g cos theta. Let me highlight that. Now this should be equal to the distance AB plus VA square. Here 2 will come. So this U is unknown thing. 2, 10, cos 45, 4 by 5. Distance AB is 2. VA square will be 32. Okay, simplifying this. U square equal to this will be 2 48. And 1 by 2 2 16. 16 plus 32, 248. Okay, this will be our answer. Okay, fine. So this is the basic idea. I think it's some very good problem where you are applying a lot of ideas here. Once again, the acceleration of box along the incline and acceleration of particle along the incline are g sine theta. Okay, fine. So there is no relative motion between the particle and the box. The relative motion between the box and the particle only normal to incline, and that is g cos theta. So therefore, where all g is there, we should bring g cos theta. Agree this? Then, so okay, sir, what is this formula? If you project a particle from a point with what minimum speed you should project so that it will cross through the point P. I think this is what I derived. Check the earlier videos. So here g cos theta has to be applied here. And what is y? Y is the vertical separation. What is y? Y will be vertical separation. Between A and C, we are applying this one. This particular concept we are applying for A and C. Here I'm showing it. From A to C, we are applying. So with what minimum speed you should project from the point O so that it should pass through A and C. So when you're projecting with minimum speed at O, definitely the particle will have minimum speed at A and C. So I'm describing the same concept instead of from O to P here, from O to this one. From A to C, we are applying this. This is the idea of the problem. Huh? So are you projecting from O or A? I'm projecting from O only. As it is passes through A to C, I can describe projectile motion between A and C. That's what we applied here. Hope, are you getting the basic concept now? So there's a path. There's a path. There's a path. Okay, now there's a one best problem. You must really try to understand the multiple ideas involved. So we took help of some minimum projection for a particle to pass through a point, relative motion, inclined projectile little bit, then a conservation of mechanical. We don't want to apply conservation of mechanical, apply projectile motion from O to A and you can solve, we'll get the same answer. Okay, kids, we'll take the next problem. Okay, kids, now we have a problem related to inclined projectile and relative motion. Both are combined in this. So we have a particle is projected up an incline at t equals 0. So here we are projecting a particle at t equals 0 with speed 14 meter per second. Let me indicate also. This is the speed with which we are projecting. And there's a point of projection. Let's say call A. Then, and at an angle 30° from the incline, 14 meter per second. At the same moment, a box starts sliding. This is the box. At the same moment, a box starts sliding down. The box has two small holes. Here, at a height 2 meter on the opposite walls, the particle will enter and will pass through it. Okay, there's a rough diagram. The particle is so projected that it will pass through like this. It will pass through them. Agreed? From first window and leaves the other. Okay, sir, where are the windows? Okay, the windows here. There's the first window. There's the first window. And there's a second window. Agree this is asking to calculate this particular width of the box, which we have to calculate. So let me call this width of the box as X, or say L will call it. The width of the box, we'll call it as L. No. How to solve this problem? So actually, when the particle, what are the acceleration part? Particle will have two accelerations. One, box will have acceleration g sine theta. Particle will also have acceleration along the incline. How much? G sine theta. And normal to incline, g cos theta. So there is no relative motion between the box and the particle because both are having g sine theta, g sine theta. So there's no relative motion between the box and the particle along the incline. So where is the box? This is the box. This itself is a box. First will conclusion. No relative motion between box and particle along the incline. So we will make a simplified approach. So what we are going to do is like it. We are assuming like this, and there's a box. And now the acceleration here will be g cos theta. We are describing this in the frame of the box weapon, and we are projecting a particle from here. You call it an angle. This is theta, g cos theta we have taken, no? U, where alpha will be 30 degrees. This assumption we have made. And the particle will go like this. And this is the, the first window. And this is the second window. Those windows I'll show by some color. And the particle, what happens, will pass through it. What is the height of these windows? 2 meters. Okay, done. So I think it's quite easy, and we have to calculate this length. We don't know this distance. Call this is x. Call this is y. The height of the windows, let it be y. Now directly come to the projectile concept. We are projecting the particle from here. This is the point. This is the point. So we are bringing this whole concept in the frame of box. Now we'll write down the equations. So first, actually, the particle will cross at B. Then it will pass through the C. So from A to B, we'll write the equation. Then again from A to C. From A to B. What is the equation? Y is equal to x tan theta. What is the angle of projection alpha? Minus g cos theta Hope you recollect the basic projectile equation. G cos theta. So here G cos theta in projectile motion, it will be G cos theta. Here alpha will be the angle of projection. Alpha is the angle of projection. In place of G cos theta is there, and this is x square by 2 u square cos square alpha. So this is a basic equation. So what is value of y? Y will be equal to how much? Y will be 2. X we don't know. Tan alpha will be 30 degrees. Will be 1 by root 3 minus G will be 10. Cos theta, cos 53. Cos 53. 3 by 5. X square, we don't know that. 2 u is how much? 14 square. Cos square alpha. Cos alpha will be 30 degrees. Huh? So root 3 by 2 whole square. So this will become 2 x by root 3 minus this will be 5 6x square. Here 2 14 square 196 196 into 3 196 1 2 here 2 square 2 will come 196 by 2 98 into 3 294 6 divided by 294 1 by 49 this is one equation of calculations. Let me okay, fine. So like this, we'll have there's a one equation. Now, similarly, from A to C will apply it. From point of projection to second window. From point of projection to second window. Here. From A to C is what we are going to apply it. Earlier, what we discussed is from A to B, this particular thing. And from A to B is what we ended up this equation. From A to C, again, what is y equal to x plus L tan alpha. Alpha is the angle of projection, not theta. Minus G cos theta x plus L whole square by 2 u square cos square alpha. So y will be 2. X we don't know, L we don't know, by root 3 minus G cos theta. This everything G cos theta will be 6 will come. and 2u square cos square alpha. This everything will become 294. So this will become 2x plus L root 3 minus x plus L whole square by 49. We have to solve these two equations. Then solving 1 and 3. Solving equation 1 and 3, we'll get the L, which is the width of the window. Okay, you have to solve this. I think I'm decide to simplify. Equating 1 and 2. We'll get L, and X. I think first we'll solve for the quadratic equation we'll get here. Here we'll get quadratic equation. Solve for X. Then the value of X substitute here. Again, we'll get quadratic equation. Again, you have to solve for L. I think it's a pure math. I'm leaving this to the student. Please work out and tablet the answer. Well, I think I'm answer somewhere. I had to work out. I just saw a good problem. I brought it here. Okay, kids. So what is the basic idea of this one? So we are projecting the ball from the a point on inclined plane with a speed of 40 meters per second. At the same time, the box is released. Then this is going to pass through the box like this. And both the windows are at same height. There's no relative motion between the box and the particle along the incline because both are having g sin theta, g sin theta. There's only relative motion perpendicular to incline, and that is g cos theta. So we are going to make this everything like a projectile, oblique projectile. The idea of oblique projectile we're bringing. And instead of g, we should take g cos theta. That's the one basic condition here. Then, so we'll use the equation of trajectory of the projectile. I'm projecting the particle from point A. Then it has to pass through the point B. Then what is the height here? Height will be 2 meters and x is the distance of the box. So this will be the parabolic path. Fine. And this will be the, so from A to B, we apply like this. Y equal to x tan theta minus g cos theta, this one. Similarly, from A to C, from A to C, again, we'll apply the same oblique projectile particular problem, the particular equation, and solving, we'll get this particular equation. Solving equation 192, we'll get the width of the box. Okay, thank you, kids. Thank you for watching my channel. Thank you. Hello, kids. Now we have the pathfinder problem. It is. Question number 13. Very good application problem based on the inclined projectile. So we have a grasshopper on the bottom of a cubicle box. This is the grasshopper. Has to jump out of the box. Each side of the box he has given h. This length they're given. So this is h, this h, this h. And it will jump with a maximum velocity. This particular velocity u given, and it's telling maximum. I think this condition we are going to take it. What be the minimum tilt angle theta the box? So this is theta. This is called like a tilt. So that grasshopper can jump out of the box. So it has to come out of this. So we'll see like what is that some ideas of maximum initial velocity. And next is telling minimum tilt. these two are very important words which will determine how we should think on the problem. I'll underline it. These two conditions, one side is telling maximum initial velocity, minimum tilt is asking. How to include both these conditions in our problem? And those two, the initial velocity, maximum initial velocity and minimum tilt, they are going to help us to assume the conditions here or assume the basic necessity ideas for problem solving. So let's assume that the grasshopper and it will move in a path like this. And how it is projected, it is going to jump with a velocity now you have to ask questions of why you are assuming this particular angle. Okay, this will be theta. So in fact, this is the grasshopper. Why we should assume this to be perpendicular? It's telling maximum. When you project with a maximum, then only we have to assume it normal to the base of this box. That when it is crossing, it must have the velocity that should be directed perpendicular to the side wall of the box. In that way, what when it has to make a jump. Let me draw it. Fine. So why you are putting these conditions like this? Okay, there's at point A, it will make a jump. There's a point O, and there's a point B. At A, it will jump with a velocity u perpendicular to the base of the box. When it is leaving the box, it must have velocity normal to the wall. Then only what happens that minimum tilt and the maximum initial velocities are included here. Since you are projecting the maximum initial velocity, so I'm projecting it perpendicular. And the tilt has to be minimum. So therefore, the velocity has to be here perpendicular to the wall BO. So I have only these two things. Based on this, two ideas is what the problem solving has to be considered. Once again, I'll repeat it. Since the grasshopper is having maximum initial velocity u 3 meter per second. So since you are projecting with maximum velocity, so therefore it will jump normal to the base of the box. For the tilt to be minimum, okay, the velocity of the grasshopper when it is crossing the edge, it should be directed perpendicular to the this side wall BO. And now we'll resolve this G. We'll resolve this G into two components. One, so let this be the angle alpha. This total length is h. Here also this AO, this one, OB also equal to h. Now this will be G cos alpha, and this will be G sin alpha. This theta is unknown thing which you have to calculate. OB CD. Okay, then OB, CD, and CO. All these are equal to H. So we'll write down the equations of motion from A to B here. And how we are going to write? We are going to write along OB. For parabolic path AB along OB. Final velocity is 0. It will have some velocity. I'm not telling it will not have velocity. It will have velocity, but it will be directed normal to the OB. So then what is the component of velocity along OB? Along OB, it should be 0. Fine. Now we'll write down this one. This will be final velocity will be 0. 0 square minus q square 2 why this positive sign? Why this negative sign? Because this g sine alpha is directed opposite to initial velocity, and this h, this length, this h will be measured in this direction. So this h is a positive. So u square 2g sine alpha into h. Let me substitute all the values. 3 square 2. This will be 10. Alpha we don't know. Sine alpha. In the bracket h is how much? 0.5. So sine alpha will be 9 by 10.4, which is 0.87. With calculator, I'm using a, we have to use calculator, there's no other way. So the alpha will be sine inverse of 0.87. In calculator, I'm getting this angle as 59.92 degrees, which is approximately 60 degrees. If alpha is 60 degree, this will be 90. This will be 90. Then theta should be how much? So theta plus alpha. Therefore, theta will be 30 degrees. This will be your answer. So our answer will be very simple. I think it's all about this condition. This condition is something very important. Maximum initial velocity. So therefore, I'm projecting it perpendicular to the base of the cup, base of the cubical box. And since the tilt angle has to be minimum, so it will graze the upper edge such that the velocity will become perpendicular to the side wall. So then we'll apply equations of motion from A to B or along OB. Then what is acceleration due to gravity? G will be there. Resolving this will get G cos alpha. Sorry, G sine alpha. This direction it will be G sine alpha. That we are applying it. It is a very simple problem. I think we have to really put effort in understanding this one. Rest of problem solving is very easy. Based on these things, I'm assuming it, and this is the parabolic part. Okay, kids. Thank you. Thank you for watching my channel and learning like a physics from my channel. Really very happy to see that a lot of you have given your affection, and with honestly, you are preparing to my channel. In fact, I'm really feeling very happy that okay, somebody is using this content. Okay, all the best, kids. Carry on. A ball is thrown from the inclined plane, So there's a point of projection. It is going to move in a parabolic path. It will collide. Again, it will rebound. And every time the angle of rebound will be same at an angle theta from inclined surface with initial speed u0. For the resulting projectile motion after hitting the surface, ball rebounds at the same angle theta. This is a condition given. So this angle theta will be same for all the after every rebound with the horizontal. Fine. So it's going to move like this parabolic path. Then again you check that again the angle of rebound again will be same. Again after second rebound again the angle of contact will be same. Again it will continue like this. This is a condition given. But with reduced speed u0 by beta. So u0 initial projection, then u0 by beta, u0 by beta square. And it continues. So it's asking to get the magnitude average velocity of ball for the entire duration of motion. In terms of u0, we have to express. So here we'll assume things like this. We'll bring the normal to incline everywhere. These lines are normal to incline. Over the speed of projection u0, along the perpendicular to incline will be how much it will be u0 sine theta. And along the incline, it will be u0 cos theta. This is the initial point of projection. We'll write it as letter A, B, C, D, and it will going to continue like this. Further, if I stretch it, this is one basic idea of the problem. Now how much it will be? This velocity should be u0 by beta cos sine theta. And this velocity will be u0 beta cos theta. This velocity will be u0 beta beta square cos theta. This velocity will be u0 beta square cos theta. This is sine theta. u0 beta cube sine theta. Along the incline will be u0 beta cube cos theta. Here it will rebound with a speed I don't have place. I'm dumping everything here only. u0 beta 404. So y component of velocity normal to incline will be u0 and we have the range. One particular this will call range R1, R2. This is R3, R4, R5. Time of flight, let it be T1, T1, T2, T3, T4, T5. The angle of inclination will be 37 degrees. The diagram little bit everything have dumped it there only. So this part I'll remove it. Rest everything you can manage. very small, I'll write it here. Okay, this angle will be 37 degrees alpha, angle of inclination. I will write the projectile equation. What is the time of flight for the projectile? What is the time taken to move from A to B? Directly, I'll write it from A to B, or A B. I'll write it. This should be equal to time of flight will be T1, which is equal to 2 U naught sine theta. I'm going to resolve this G here. If this is the inclined plane, this alpha, this will be G sine alpha. This will be G cos alpha. So along the inclined plane, how much it should be? G cos alpha. Those things I'll indicate here. Let me indicate. How much it will be? G cos alpha. And along the incline, let it be G cos beta. G sin alpha. Okay, fine. And this is R1. I think I don't have a place to show that. Projectile motion. Hope you are able to see that area under the parabolic curve. At least this is the parabolic path. This length will be R1. I'll show it here. Right. I'm going to will determine the time of flight, this U naught sine theta and G cos alpha. So 2 U naught sine theta by G cos alpha. Let this be fundamental, let it be equal to T. Okay, then what is the expression for range? R1. R1 means the range measured from A to B. RAB, R1. That should be equal to, it depends upon this U cos theta and the time of flight. So I'll put it once again. The range from A to B, it depends upon this U cos theta, G sin alpha, and time of flight. Using S equal to UT plus half AT square formula, velocity along the incline, U cos theta, time of flight T1 plus G sin alpha, T1 square. So this will become R1 equal to U cos theta, 2 U naught sin theta by G cos alpha. I think I'll make it generalized. U cos theta. This will be T square all divided by 2. This is a range. Similarly, time of flight from B to C. What is the vertical component perpendicular to incline? U naught B sin theta. And acceleration is G cos alpha. So based on that, the formula will be 2 U naught beta by G cos alpha. This should become equal to T by beta. And the range R2, RBC equal to R2, which is equal to U naught by B cos theta T2 plus G sin alpha T2 square by 2. Simplifying this, T2 will be T by beta. T2 will be T by beta whole square. Okay, this will be 2 beta square. So let it be. So this is the R2. Similarly, we'll calculate R3, R4. We'll get some basic idea, then we can generalize it. Then P3 will be from C to D. So this will become 2 times of U naught beta square. Here, this one. Beta square sin theta by G cos alpha. This should become equal to T by B square, time of flight. Then the range will be RCD, which is equal to R3. This should be equal to velocity along the inclined plane, U naught I'm referring for this one. U naught beta square sin theta will determine the time of flight. U naught beta square cos theta, this one. And G sin alpha and time of flight will determine the range from C to D. So this should be equal to U naught beta square cos theta T3 plus G sin alpha by 2 . So T3 will be P by beta square solving this U naught cos theta so on like this we can go for it. So we will average velocity is asking more. First we'll get expression for the average velocity. All the terms are there in front of us. Average velocity will define it. V average equal to total distance covered. AB, BC plus CD plus DE and so on by time taken to move from A to B. TAB which is equal to time, the range. So there's nothing but distance AB R1 is nothing but equal to AB. R2 is nothing but equal to BC. R3 is nothing but equal to CD. We'll substitute all the values. This will be, I'll write down here. U naught cos theta plus G sin alpha by 2 P square. Next, BC will be, this is the BC. This will be CD. Okay, I'm rounding off all. Those who are getting confusion, just take help of this rounded off things. At least you'll get in a basic picture of what is this, all this equation. Okay, now let me substitute the BC value from the data. So this is 1. Next, BC will be U cos theta T by beta square and so on, all divided by time of flights. Time of flights will be time of flight T1. T1 is 2 U naught sin theta G cos alpha. Or time of flight, we know that this will be T. Next, TBC is how much? TBC is T by beta. T by beta square and so on. So we'll take U cos theta. T will get eliminated. So U cos theta will come in common. U cos theta by T. 1 plus 1 by beta square. 1 by beta to the power of 4. And so on. Then similarly, G sin alpha T square by 2. Beta square. And so on, all divided by T, I'll take common. And so on. So here T will get eliminated. U cos theta one plus beta square and so on divided by 1 plus 1 by beta so use the conditions of sequence and series from that you can solve and we'll get expression for the average velocity. Asking together duration of motion, then the value of beta is asking. So we know the value of U theta and we can calculate the time t also. We'll continue. I think this is U naught symbol. U naught. So further this will be the average velocity, how much it is given, this should be equal to u naught. So the next step will be u naught is equal to u naught cos theta g sin alpha by 2. Time of flight will be, time of flight is how much it is given, is it, we have derived now earlier, 2 u naught sin theta by g cos alpha equal to the bracket term. This will be 1 by 1 minus 1 by alpha whole square. This part, this whole upper square bracket 1, simplification will be this much. Divided by here 1 t is there. Time of flight, this will be 2 u naught sin theta by g cos alpha. This bracket will be 1 by 1 minus 1 by alpha. So u naught will get eliminated. The question is asked, no, the average ball of entire direction of motion is u naught, then the value of is asking. So u naught will be eliminated, then we'll get this as u naught will cancel out here. This u naught, this u naught, this u naught. U naught will get eliminated, then this will become t will not be there. This t will not be there. Okay, the u naught will get eliminated, so this will become 1 by 1 minus 1 by alpha equal to cos theta plus g will get, t will get eliminated, so tan alpha sin theta 1 divided by 1 minus alpha square. So this further, this will become 1 by alpha cos theta tan alpha sin theta 1 minus 1 by alpha one plus alpha. Little bit calculation part is lengthier. So these two will get eliminated. So we'll get 1 plus 1 by alpha equal to cos theta plus tan alpha sin theta. What are the values here? We have cos theta 53 degrees. Let me simplify. 1 plus 1 by alpha cos 53 degrees tan 37 sin 53 degrees. Cos 53 degrees. The value of cos 53 0.6. The value of 37 0.7. Sin 53 will be 0.8. And multiply further 0.75 into 0.8. 0.6 will come. 1 plus 1 by alpha equal to 0.6 plus 0.6. 1 plus 1 by alpha equal to 1.2. 1 by alpha equal to 1.2 minus 1 will be 0.2. Alpha is 1 by 0.2. 10 by 2, 5. So therefore, alpha value will be equal to 5. This will be your answer. Little bit lengthy calculations remaining all manageable with the projectile motions. Okay, kids, I think we have discussed some best problems related to various ideas of the inclined projectile. Coming class, we'll discuss few more better applications one. So thank you all of you. Thank you for watching my channel. And I really appreciate most of you are asking doubts also in this channel. Please do like, comments, and share this channel to others so that everyone will get benefited. And I'll promise that this won't be deleted or the channel will not be like a made a subscription. Like I'll not demand any money. So somebody questioned me like, okay, sir, once it becomes popular, what you do? I'm already working in college, so there won't be necessity for me to demand anything from students. So just make use of it. I'll be very happy. Okay, thank you all of you.